I always pronounced this word, epoch, and this word, epochal. I pronounced this word, epochal. Going back, I tried the pronunciation.
Epoch.
Epic.
Epoch.
Epoch. Epoch.
Epoch.
Epic.
Epoch.
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 So, some people pronounce this word, epoch. Other people pronounce this word, epoch. Epoch.
Epic.
Epic.
Epoch.
Epoch.
In this case,
Epical.
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 they pronounce this word, epochal.
Epical.
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 Epical. Epical. Today is January 22nd. This is my 201st episode for C++ 17, 20, 23, CUDA, SQL, etc. This is 31st episode for vector calculus. In this episode, functional programming for gradients and curves. Scroll down. In this section, C++ library extensions. Before filming video, you can double-click this link to download my previous source code for C++ extensions. After filming video, you can double-click this link. Of course, I haven't uploaded this library yet. If you want to follow my current session, I assume you have watched episode 200 Vector Calculus 30. Please double-click this link. From this video, Mr. Marcus Buchholz, I remember his name. Congratulations on your achievement. 200 perfectly done episodes is an impressive achievement. Good luck. Thank you, Mr. Buchholz. Your name is familiar with me. Lossless SS. Please make a complete video of your assembling the new desktop. It will be beneficial. Thank you, Mr. Lossless. But I don't have two hands that can hold my camera while assembling my desktop. I don't have hands. Come over to Korea and hold the camera for me. Thank you, Mr. Lossless. DW, interesting. What can we do with the new Intel graphic cards? We can do many things. We can process our data in parallel. Thank you, Mr. DW. Scroll up. From my previous episode, download the current video source code. Click it. I think I already downloaded. I will unzip it. Rename 201 gradients and curves. Copy, paste it in your working directory. Open up Visual Studio Code. CPP 17, 20, 23 parallel. From folder 201, double-click this file. Ctrl B. You need updated library. Okay, you need updated library. After filming this video, you may have to download the updated library. If you haven't watched my previous episode, you may not understand what we are doing or what I am doing in this episode. I would copy this video link. Copy, Ctrl N. We implemented this function in our previous episode. Control N. Void review partial derivatives. Copy this function name. Copy. Control N. Paste it here. If you leave your comments and kind messages, then I can be kind to you. By being kind, I mean I can give you more detailed descriptions about my algorithm, such that you can further extend my library for your own needs using namespace, CPG, operators and constants. Using namespace, CPG, numerical analysis, we need commands. In operators and constants, in this file, we define power operator, such as _0, _1, etc. We also define constant by square root 2. Here again, in numerical analysis commands, go to definition. In this file, you can find dx1, dx2, all these things. These are for differentiation, also for integration. Now, here, auto f, I define arbitrary function, auto x, auto y, auto z. This is arbitrary function. We return x times y square. It should be _2 with parentheses. g to the third power, or g cube. We defined arbitrary function. We want to differentiate partial derivative, or command dx dy square, then dz. You can try any name, then create command. We can pass dx1. It means we do derivative with respect to x. 1 represents first order derivative, then dy2. This means we are taking partial derivative with respect to y twice, or second order derivative. I will just try with this. Then you can try with more. I will fix like this. Then auto df dx dy2 CNA partial derivative. We pass this command. Here y is bigger, probably CNA. Create command. We pass 3 values for x, y, z. For example, 1.0, 1.0, 1.0. SED, cout. We can display the value. CPG, and there. Sorry, I forgot passing function f. Here, I fixed. Scroll down. I will copy, paste. Now I will change it to dy dz2, then dy1 dz2. We pass this command here. I will rename dy dz2. Copy this, paste it here, paste it here. Now I will copy this, copy, paste. I say dz3. Here we can simply pass dz3. Copy this, paste it here, paste it here. In this case, we are differentiating this function with respect to z. This is third order derivative with respect to z. Right click. I made a mistake. In this case, when n is 0, integral arg, this value is 0. When n is 0, it should be 1. I found this bug. For example, base to the 0th power should be 1. I fixed the bug. Now we will run this function. I removed blank space. Open up any compiler. cd 201 gradient and curls clang plus plus sed c++20 grad.cpp ltbb12 oc.exe. Hit enter. It will build cls c. Wow, beautiful. See, we passed 1.0, 1.0, 1.0 for x, y, z. In this case, we differentiate with respect to x once, with respect to y twice. Then the result is 2. In this case, we differentiate with respect to y once, first order, with respect to z, second order. In this case, 12. This is correct value. In this case, we differentiate with respect to z, with respect to z, third order derivative. 6. Correct. Perfect. Who do you think can implement such partial derivative algorithm? It is super powerful. It took me 3 years to implement this algorithm. Now, let's move on to functional programming. In our previous episode, we created this function. Copy, Ctrl N, paste it here. Scroll up. I will rename functional 1. Copy this function name. Copy, Ctrl N, paste it here. Disable it. Scroll up. Let's consider about this function that we created in our previous episode. If you haven't watched this video, please watch it. In this code, this function f is a potential function such as electric potential or gravitational potential. From this potential function, we generated gradient vector. This gradient vector is a scalar. It is scalar vector. This is problematic. With gradient vector, we have to do work. Not this work, but this work. Okay, we have to do work. To do this gradient vector should be integrable. But we can't because this is scalar vector. From potential function, we have to generate integrable function, not values. Anyway, let's try to build. We will rebuild CLSC. It works as in our previous episode. From this potential function, we will create gradient vector, but elements are functions. Right-click, go to definition. In this function, gradient vector, we return BCTR3D. Each element is a scalar value. Now, here we create a new function, template, callable with 3 floats C, fun type, or gradient, fun type function, no except. Sorry, I will cut, scroll up, I will paste it here. Now, using namespace commands or fx, we capture function std floating point arg type x, arg type y, arg type z. We are creating a lambda. We return partial derivative. We pass dx1, this function here, by passing x, y, z. So we are differentiating this function with respect to x once, first order derivative of a function by passing xyz. xyz are the parameter of this lambda function. Copy, paste. Now this is fy. We do derivative with respect to y. Copy, paste. We do derivative with respect to z. So it should be dz. Now here we return std tuple. We pass fx, then fy, then fz. Here we implemented gradient. This gradient takes function. It does not take arguments yet. Now here we call gradient by passing f. We don't need this. We say gradient f x y z. This is function. Now we say or grad f equal cna create vctr3d. We can't call it directly. Instead, I say fx, fy, fz. From this fx, we have to pass three values for position vector. Like this, it should be floating point values. So this is fx, copy, paste, paste. This is fy, fz. So this function returns a new vector whose elements are fx, fy, fz. These are function itself. With this, we can rebuild CLS C. The result is exactly the same. Why we need this kind of programming? Because we have to do integration with gradient vector. Gradient vector generates vector field. In this case, for example, gradient V. This E, electric field, represent fx, fy, fz. Please note, we passed function f. This function f takes three parameters. Then this gradient function returns three functions. We passed single function, but we received three functions. Each three function fx takes three arguments. Function fy takes three arguments. Function fz takes three arguments. We will do integration with fx, integration with fy, integration with fz. This is not triple integral. How can we do integration with three variables? This is not triple integral. Don't worry. We will parameterize variable x, variable y, variable z with t, time. So you don't need to worry about such things. This part is very ugly. Now I will copy this. Copy, paste. I will rename 2. Copy to this function, Control and paste it here. I will disable it. Now scroll up. This part is very ugly. Right click, go to definition. We are calling this function. This function is defined in the cpg vector.hpp. Now here template collable with three floats or float c 펑 x copy paste I will arrange 펑 y 펑 z then SED floating point ARG type auto create VCTR 3D SED tuple 펑 x 펑 y 펑 z constant 펑 xyz then ARG type x ARG type y ARG type z. I would use no except. Here also I will use no except. Also no except. Also no except. We don't need exception. Now, here, although we can use L-value reference, fx, fy, fz, from xyz, we return VCTR 3D, we call evaluate fx, x, y, z, copy, paste. This is fy, fz, semicolon, remove trailing comma. With this, we can fix this part. Instead of doing this, we say E. Of course, we have to put negative, but I haven't implemented it yet. Instead, we can pass E, then 3 floating point numbers. With this, we can build again. CLSC. It works as before. This is still ugly because we can define this point here or faced. This point can be CNA create VCTR 3D semicolon. It should be floating point numbers like this. I will disable copy paste. Instead of doing this, we can simply pass point P0. This is position. It means evaluate gradient vector E with position vector P0. We haven't implemented this function yet. Instead of E, I would use G. So I will change it to G. I haven't implemented this part yet. So I change it into G. It should also be G. Now right click this function once again. Here we can copy this, paste it here. Instead of doing this, we can say VCTR 3D ARG type. I will remove XYZ like this. Constant P. P is position vector. Now we can simply call this function paste. We pass from XYZ, then delete P M X P M Y P M G. This is a function. We are redirecting to this function. With this now should work. We will rebuild CLSC. Of course, it should work.